Greetings. Welcome to the mothership. Welcome also to Calculus in the PM. I'm your host, Mr. Shandelka. Integration by parts we're looking at. This is 30L, integral calculus course. Now, you know when you did substitution, it's sort of the opposite of the chain rule. Substitution is regular calculus, 30, right? Well, integration by parts is the opposite of the product rule. So let's just take a look quickly at the product rule. Oh, didn't mean to cross that out. But anyways, what does it state? If f and g are differentiable functions, then the derivative of f times g, so that's, you know, x squared plus 3 in a bracket, x cubed minus 2x plus 5 in the second bracket, or whatever. Anyways, we know how this works. Derivative of the first thing, leave the second thing alone, added to, first thing left alone, derivative of the second thing. Well, this is a portion of that work backwards. I'm going to ask you to rewrite this rule in a notation for indefinite integrals and isolate for this part of your expression. So I'll work this through with you. So what I'm saying is if you were to take the integral of the, like, basically if you didn't do this, you guys, the opposite is undoing the derivative, right? So what we're saying is f and g of x. So if we take, sort of integrate this whole expression. Okay. So we've got, maybe I'll use a color system, maybe I won't. F of g. F of x, g of x is equal to the integral of prime of x, g of x, dx. The integral of f of x, g prime of x, dx. So that's what I meant by the first thing. Rewrite this rule in the notation for indefinite integrals. Okay, I've done that. And then algebraically isolate for the last thing on the right-hand side. So really, pardon me, what I'm doing is actually to get rid of, to isolate this, I want to subtract this portion, right? But I'm going to left-right switch it just so. So, like I said, I'm going to left-right switch this, f of x, g of x. I caught myself there. G of x. Oh, it's going to disappear and switch pens on me. Okay, now okay, so I've isolated. Now, what we have here is the integration by parts formula. But it's really clunky. The notation, this notation is hard to memorize. I don't know why I have it twice. It's doubly hard to memorize. So. Okay, this notation is hard to memorize. Let me just count this. It's easier to recall the equation if you apply the substitution rule with the following substitutions. We'll let u equal f of x and v equal g of x, okay? So u and v instead of f and g for our functions. And this is common. This is what you see in most textbooks. So what we have above here, we're going to say u, and then, well, we've got to think this through here. we're going to substitute this in here, then what's du? According to this. Du by dx, what's that? If u is equal to f of x, sure we don't have an expression, but what is it? Du is the derivative. So we'd call it, with the f of x notation, what's the derivative? F prime of x dx. So anywhere you see f prime of x dx, you're going to replace it with du. And dv, this is not velocity, it's using v though. Same idea. Anywhere you see g prime of x dx, you're going to replace it with dv. Okay. Okay, so the above rule becomes, we'll sub it in. Subbing it into the rule above here. F of x we replace with the letter u. I want to see that though. G prime of x dx we replace with dv. It's just way easier to read, and you can memorize it. F and g become u and v. Subtract. F prime of x dx, the gx as well, but this part we're going to use du to express that, and the g of x is v. v du. That doesn't tell us how to use this rule, but first things first, okay? Really what I want you to get out of this is that this formula doesn't come out of thin air, right? This is the same formula. I have it typed there for you. Okay? We're going to apply this formula over and over and over and over and over, several times anyway. Okay, so you're not going to have to memorize how to come up with the formula. And I would, if you're going to take this in Math 111, your second, in Regina it's called Math 111, your second course, and you might jump straight into it if you're in credit in your AP exam, you'd be using this in Math 111 for a section. Anyways, integration by parts, let's use this formula when you can't solve the given integral. First look though, you know, first you look, can I just solve it because it's like x squared? Okay, 1/3 x cubed plus c, right? Can't do it. I can't see a substitution that's obvious. So when I'm looking at this, because if I substituted for sine, I know when I do the dx thing or whatever, du would be, if I was trying to substitute, we'd have cos of x. Then we're no further ahead. Okay. So you can't solve the given integral using the methods you guys know. Hopefully you'll find an easier integral to solve than the one you were given. If it's tougher, that's no good. So choose your u equals f of x so that the derivative of the function is simpler than f. Now, that being said here, you got two choices for the function. Is it this or is it this? Well, the way to choose, because I can't see any substitutions that work for this. If I choose u to equal x, what's my du? 1. Now that is definitely simpler, right, than what I have. If you chose it as sine of x, you've got cos of x, and it's not any simpler. It's equivalent, right? So, we're going to let u equal x, then du is equal to 1 dx, right? I won't put the 1 there, but it's dx. That means, according to this formula, By the way, it isn't necessarily, this time it looks like it's in that order, right? But this x could have came after. It could have been sine of x times the variable x. Don't assume it's in that order. But what's left over must be my dv, right? For applying parts to this. So then, dv is the rest of this, sine of x dx. Okay. Well, I need to know what v was, so I integrate, right? You can just do this, though. I'm just telling you, first time through, that's what we're doing to get to the v. So, the integral of dv on the left side is just plain old v. The integral of the sine function came from integral negative cosine of x. Okay. You need these four things to apply this formula. U, v, v, du. You don't directly need the dv to apply the formula, but you need to use that to get v, right? So hopefully this will now be an easier integral. Let's toss this in. So what I am saying, and if I use my color code, I'm just going to rewrite this question here. And I'm only going to rewrite it for color reasons. Okay. I just rewrote it, that's all. You don't have to rewrite it. But using my color scheme then. What do we use for x? What do we use? Okay. We know this one. So this is my u dv, right? Now let's go through this carefully. uv, maybe I'll just even, because I can do this. I'll just put this here. We're applying this. It's clear now what my u and my v are, right? We stated it above. Now the uv is x negative cosine of x. So we'll just call it, no, I'll sub it in exactly. I won't try any. Is that right? Yeah. I was going to start just combining things. The minus sign in the integral is built into the formula, right? So I'm getting that from above. Now, the part that I have to integrate now is the v, negative cosine of x. Put that in there. du, and my du is, in this case, just plain old dx, right? So, what I have on the left is what I want to solve, right? What I have on the right is an easier solution, hopefully. There's nothing further to do with the x times negative cosine of x other than just put the minus sign first, right? Minus x cos of x. So I'm going to drop the color scheme from here. So minus x cos of x. Now, if it makes it easier for you, I'll just think of this as cos of x dx. I really haven't done anything in this step. I just rewrote it, tidied it up. Can you do that integral? Oh yeah. I hope you can. Anyways. Okay. Minus x cos of x plus, that came from the sine function. Plus c. Don't forget the plus c because I'm a chintzy son of a bee. Take out 0.5 marks. So you get 2.5 out of 3. Forget that. Okay. I wouldn't say you've got it just by saying one of these. Go through a few more examples. Find the natural log of x dx. Well, in this case, what's the obvious choice for u? Let u equal natural log. When you do the du, the derivative of the natural log, it's simpler if you ask me anyways. Du is equal to 1 over x. Yeah, we'll operate with 1 over x. dx. Then according to that, what's my dv? It's just dx, 1 dx. Yeah. Okay. Then if I integrate both sides, not worried about a constant, by the way. Right? V is equal to x is what that tells us, okay? Now I'm trying my rule. Oh. There, get that downtown. So I'll apply this rule. According to this, I'm just rewriting only so I can see the parts, different parts. Ln of x, natural log of x, dx is equal to the u and the v, natural log of x, v is x. Now, typically, I'll write it in this order first. Typically, you would write the x in front. I don't, you already see it that way. Now the integral of v du. Now I used to have this memorized, and I go uv voodoo, whatever, just because you'd have to memorize this in Math 111. You don't have to for me. But anyways, the integral of u dv is uv voodoo. I just remembered, like that's a voodoo. Anyways, you would memorize this for Math 111. The v is x, and the du is, hey, this makes things really simple. 1 over x dx. We'll tidy this up and then just do this. Now, like I mentioned before, you typically would see the x in front of the natural log. So I'm going to just call this x, natural log of x. There's nothing left to do here, right?
Is there a plus sign?
Yeah, because I made a mistake.
Yeah.
Thank you, young man. Make sure, anyways, subtracting. X over x, that's 1. Oh, this is so simple now, huh? Got the correct sign now. 6 brownie points for Rashad today. I'm not giving them to Hufflepuff or anything like that. You get them your own. Okay. They're your very own points. Okay, please tell me. What is this? X minus x plus c. You keep your points now. Okay. Now, incidentally, you should be able to, and I forgot to mention this. So in this one, what's a good choice for you? Is it the x squared or the e to the x? Remembering your choice for u means if you take its derivative, it should simplify, it should change it so it's simpler. So x squared, because if you chose the e to the x, the derivative is still e to the x, it's no simpler, right? Okay, so u equals x squared. Then du is equal to 2x dx. And dv, the e to the x dx part, I integrate both sides. Not worried about the constant. And it's still e to the x. It's its own derivative, it's its own integral.
Would it be 1 for x?
Whereabouts?
Would it be 1
The
for
v?
x e to the x for v?
Well, let's just see if you get the original. Take the derivative of this side, you got dv by dx. Right. And the derivative of e to the x is e to the x. You're trying to tie in the natural log somehow, unnaturally.
Oh, no, never mind. I see what
So I think I see what
there's
it
no e to the ax. Yeah, so.
Okay. Right, if it was any other number, then you'd take a reciprocal.
Yeah.
I got you. If it was 2x,
Yeah.
you'd be going 1/2. See, this guy's thinking way ahead of us. Now, I'm just grabbing this formula off twice in this. This guy's a millennia ahead of us. Huh? I'll put this down here for later.
You didn't put that on there.
Okay. Back to this. I'm only rewriting just so I can see my color scheme. My u is the x squared. My dv is the e to the x dx stuff. I'm applying the rule. It's equal to u times v. So x squared times e to the x. The subtraction is built into the formula, and I've remembered that. V is still e to the x. My du is 2x dx. Okay. I take a look at this and I ask myself if I could solve this. Can you do that derivative? Or derivative of that integral? Not really. But hey, when we do it again, and if we choose u as 2x again, like the algebraic, the 2x, you see that it comes down to, when you do your du, there's just the number 2. So we have to apply this rule again, product rule again. So product rule again. Now this time is, I'm going to just put it off to the side here. U is equal to 2x du, du is equal to 2 dx, okay. And my dv stuff is the exact same as before, but I'll write it out again. dv equals e to the x dx. V is equal to e to the x. This is going to work this time. It better. So, I'm going to put this, and I rewrite it in green brackets here, just because I like the color. Just because if I don't, I'm going to make a sign error, an SIGN sign error. So, this whole expression is now equal to, as we had before, x squared e to the x minus, now I'm not going to rewrite what's in green, like you know how I did, because it's actually really done already. Do you guys get the idea here? We're doing this uv minus v du's integral again. And that's why it's really important you got this bracket here. So the u and the v in this case is 2x e to the x. Yep, it gets complicated. Just trying to think of this here. Yes. I could have taken that 2 out, but oh well. I didn't, incidentally. Do you guys see something here? And I'm not gonna undo this, but before I did this, I could have moved the constant out in front that had -2 integral, and then you wouldn't have the 2 inside. It doesn't make a hill of beans difference, but anyways. I just thought of that as I was doing this. So where was I? UV, 2x e to the x, subtracting the new integral, v and du, e to the x, wrong pen, I'm going to leave space in front of e to the x. I put the 2x for du, v du, I'm going to put the 2 in front of the v. I think of it better this way, dx. Good gravy. This better be it. I could solve that one, right?
Yes.
Yes. So I'm going to write just one color, x squared e to the x minus 2x e to the x minus negative, so adding. Now, what do we get there? 2ex. It's its own derivative, e to the x, plus c. Can you factor anything? Because chances are in the back of a book, other than the plus c, yeah, you got some common factors there. E to the x, right? Now, if I say simplify, that means factor, whatever, e to the x, but there's no common x term. The 2 is not common. E to the x bracket, x squared minus 2x plus 2 plus c for the whole thing. That might be how it's given in an answer key at the back of the book. And that can't be factored. Okay. No dice. So we'll leave it at that. Last example, and then you can work on other things. Choose your u. Which is your best choice for you in this example 4? The cosine stuff or the x stuff? The x stuff. So we'll let u equal x, and du equals dx. dv equals the cosine of 2x dx. That would mean v is equal to. Now just think of this though. When you do the derivative of sine, you get positive cosine. So the integral of cosine is positive. Involves sine.
1/2.
So it's 1/2. It's positive. It's easy to get the SIGN errors on trig functions. Okay. That's what the v could have been. Can be. Is. Whatever. Okay. Now I'm only going to rewrite so that I can see my color scheme better. You don't have to rewrite this. U is x. And then cosine of 2x. And I've forgotten 0 to 2 pi. Now, quick note. This is not truly, this is not substitution, so I'm still involving x's. So my 0 and 2 pi stay as 0 and 2 pi, right? It's not substitution like that, okay? Yes, we do. Now, Well, well, well. Where am I? Yeah, that's where I'm at. So what do we want to do here? 1/2. Let's see here. V, yeah, 1/2 x sine 2x is the first portion, right? Yeah. Because it's u and v mixed together. So it's 1/2. I'm going to put, though, the x beside it just because that's the way we're used to seeing things written. Sine of 2x. Now, we're evaluating an integral, so I'm going to put this in brackets and say that uv, we have to evaluate it from 0 to 2 pi. Okay? That's a little bit tricky. We'll forget that sometimes. You're not going to have a million of these. Minus now. V du. 1/2 sine 2x dx. Right?
It should be negative over 2, right?
What's that?
Because the derivative of cos is negative.
No, we're going backwards.
I am applying this part of the step here right now. And this is my v. So the minus sign is built in. That's where that minus sign comes from. I just did the uv step. This is the uv step here. It's okay. So now I'm doing minus the integral. Now I was going to move the half out, but I don't want to mess things up here for people. It's tricky enough without doing 2 steps at once. And we're going from 0 to 2 pi. I still haven't integrated this one. Are we good? You're not. You're not paying attention. Okay. So, we're clear on where this is from? We got to do that integral and we're good. I might as well start with the 2 pi 0 for the first part. 1/2 times 2 pi times the sine of 2 times 2 pi is 4 pi. And then when I plug in the 0, I got 1/2 0 times, okay, so minus 0. That's directly from above doing that. Then the integral. You were thinking ahead a little bit about the negative sign. So it's going to turn into a plus sign. But I'm going to still keep it here, okay? This integral itself had the 1/2 from before put into it. Don't get mixed up there. Then you could have pulled that half out, if you wish, before you did the integral. Because the sine of 2x, its integral is also 1/2 cosine, but negative, right? So, I'll notate it like this. 1/2 negative cosine 2x. Honestly, I would have grouped a few things out first, but I'm writing it with every step kind of shown there, right? That is just the integral there. So, what do we know? You can move the constants outside if you wish to make it 1/4. I will. Let's think this through. Evaluating without a calculator. So 1/2 of 2 pi is pi. What's the sine of 4 pi?
0.
It is 0 because it is 2 pi. Oh, it repeats every 2 pi. It's on the 0, right? Okay. So that's the first chunk, 0 minus 0. Minus 1/4. I'm going to move the quarter outside of that. And then negative cosine. I guess I could move the negative sign out too, right? Is it going to be too much for you to fathom? If I move the negative sign out of there, the quarter negative? I think I'll go with that, okay. So the cosine of 2 times, so 4 pi. Subtracting the cosine of 0. Well. What do we got here? What's cosine of 4 pi? 1. What's cosine of 0? Okay. 1/4 times 1 minus 1 is 0. If you just put 0 down, though, I give you 0 marks. You got to show some work for that one, like that kind of thing. Now, give her beans on this stuff over the next few.